Hello, this is lesson 3.2, and we're going to be talking about graphs of functions. So our objectives today are analyze graphs of functions, graph linear functions using the slope and y-intercept, and review graphing by transformations, and then the last thing we're going to do is graph piecewise functions. So as it says, this section begins as a review and a reminder of the things we learned about graphing linear functions and using transformations of functions. So stop to review and name the parent functions we have discussed. So I highly recommend pausing the video and seeing what you remember from the past lessons. Okay, so our first one here is a horizontal line. And as you can see, I mean, it is a linear function. It is y equals 2. Our next one, again, is linear. The equation is y equals x. These are your parent functions that all go through the origin. Next one is the absolute value function. So y equals the absolute value of x. Next one is our quadratic function, y equals x squared. And then we have our cubic function, y equals x cubed. Next is the square root function, y equals square root of x. And the last one is cube root, which is y equals cube root of x. Okay, let's continue on to the application. So the following graph shows iPhone sales in millions of units. So here's the year, and here are the iPhone sales. Estimate and interpret the function value, f of 2013. So 2013 is right here. We're going to go up where we meet the graph and then go to the left to see what the value is. So it's 150. And now notice that this is millions of units. So 6 zeros after 150. So 150 million. Next question is, what is the domain shown? So our domain is the x-axis. We start at 2011, and we end at 2015. So our domain would be from 2011 to 2015, and both of those are included because there's the closed dots on both ends. Estimate the range shown in the graph. Okay, so range, we would kind of estimate where does it start. This one's a little bit harder to figure out what it exactly is. I would, and again, it's an estimate. So um, I would start 75 million. Looking at where the dot is, it kind of goes there. Let me actually erase this so that this whole thing. Okay, now if we look at it, it's almost about halfway between 50 and 100 where 75 is. Now, the other end for the y, it's less than 250, so I would probably approximate it to 240 million. Again, that's an estimate. Okay, next thing that we're going to do is we're going to review graphing linear functions. Our slope is usually, or it is marked with an M, and it is rise over run, which is y2 minus y1 over x2 minus x1. Slope-intercept form is y equals mx plus b. And again, m is the slope, b is the y-intercept. And then our point slope form, so if we're given a point and a slope, it is y minus y1 equals m, the slope, times x minus x1. Okay, let's continue to graph linear functions, identify the domain and range of each. So we're going to start with that y-intercept. So it intercepts y at 1, and now these are all 1, 2, 3, 4, 5, 6. I'm going to do this one negative 2 by 2's just because it's hard to fit all of them in. 2, 4, 6. Negative 2, negative 4, negative 6. Okay, so 1. And then our slope is 2 over 3. So 2 up, 1, 2, and 3 to the right. 1, 2, and 3 right here. Again, 2 up and 3 to the right. And then we're going to graph a straight line through these points like this. There we go. So our domain here, just like all linear functions, it is negative infinity to infinity. Our range, same thing, is negative infinity to infinity. Okay, next one. We have our y-intercept is now negative 2. So we're going to go down here. Negative 4, negative 6, 2, negative 2. This one's 2, 4, 6. And 2, 4, 6. Negative 2, negative 4, negative 6. And then our slope is negative 3 fourths. So it's gonna be going downhill. So instead of going up 3 and 4 to the right, we're gonna go down 3 and 4 to the right. So 1, 2, 3, 1, 2, 3, 4, right here. Or what we can do is we can go up 1, 2, and 3, and 4 to the left. 1, 2, 3, and 4 to the left. There's our downhill graph. Now, our domain, just like all linear functions, is going to be negative infinity to infinity. That does not change. The same with the range. There's no limitations on either one of them. It keeps going and going, left and right and up and down. Okay, next we're going to look at 8x minus 2y equals negative 10. So this is in a standard form. We have two options here. We can either solve for the y, or we can plug in the x and y intercepts and graph it with that. Now, what I'm going to do here is I'm going to solve it for y first, and graph it with the slope-intercept form. So we want to subtract 8x from both sides to isolate y, divide by -2. So y equals -4x. Hold on, we're dividing by that, so that's a +5. So our slope-intercept form now is y equals -4x plus 5. So our y-intercept y is right here. -2, -4, -6. And then our, hold on, this should be a plus. Because it's a negative and a negative. I'm like, something's not right. So it is a positive slope of 4. So what that means, rise or run, we are going up 4 and to the right 1. Well, if we start going up 4, well, 1, 2, 3, we don't have enough room here to go up 4. So what we need to do is we need to go down 4, 1, 2, 3, 4, and now to the left 1. So there's our first one. 1, 2, 3, 4, and left 1. It's the same thing as going up and to the right. Okay, now, oops, that's not a straight line. We'll see how, okay, I was able to. 1, 2, 3, 4. There we go. Okay, for this one, our domain is going to be all real numbers. And our range, same thing. Again, it is a linear function, so it is all real numbers. All right, our fourth one is going to be y equals 3. That is a horizontal line of y equals 3. 1, 2, and 3. Let me see if this helps me to graph it a little bit better. A straight line. There we go. That is much better. So again, 1, 2, and 3. Our domain for y equals 3 is still -infinity to infinity, all real numbers. It keeps going and going to the left and the right. Now, the range is not going to be. Because it is a horizontal line, our range is just going to be 3. And that's it. It does not move up or down on the y-axis. It just stays at a 3. Okay, next one, we're going to look at transformations to graph each function with its parent function on the same set of axes. So now, what we did up here with the parent functions is what we're going to be using when we are graphing the transformations. This one has a negative square root of x. So our parent function here, I'm going to graph the parent functions with the blue. So our parent function looks something like this. Now, remember that that negative reflects it across x-axis. So that means that it comes down here, something like this. Okay, it's asking for the domain and the range. The domain, we start from the y-axis. So it starts from 0. 0 is included, and keeps going to the positive side of the x, so towards the positive infinity. Our range starts from the x-axis, so it starts, actually, never mind. You know what? We need to start from the bottom. It is on the x-axis, but then it keeps going down and down and down, and it keeps going to negative infinity. So we start from negative infinity and end at 0. So we always put the negative first to the left. Okay, y-intercept. Well, that's going to be a 0, or we can write it as an ordered pair, which is 0, 0. Same for the x-intercept, 0, 0. And again, sometimes you might see just a 0, which is totally, or it's correct as well. Okay, next one. We have an absolute value function. So the parent function looks something like this. And now a reminder, this plus 1 right here, which is inside the absolute value, we are going left 1. And this plus 2 that is outside of the absolute value is up 2. So what we're going to do is we're going to go, actually, let me go a little bit farther. Up 2 and left 1. So our first point would be somewhere here, and then it would spread out this way, and it would keep going this way. Okay, domain, our x does not change. That's going to be all real numbers. It keeps going and going to the left and going to the right. Now, our range is the one that changes. As you can see, it starts from that 2. 2 is included, and it keeps going up, so it is to the infinity. Our y-intercept is right here. Now, how do we know what the y-intercept is for sure? What we're going to do is we're going to have to do a little bit of calculations here. So y-intercept, we set x2 equals 0. So y equals 0 plus 1, absolute value of that, plus 2. So y equals absolute value of 1 plus 2. These are absolute value signs. Y equal, y equals 1 plus 2, which is 3. So our y-intercept is 3. So it's going to be the point 0, 3. Now, does this graph intersect the x-axis? No, it does not. There's none. There's not a x-intercept. Okay, next one is a quadratic function. So y equals 2x squared minus 1. We're going to do the parent function first, which looks something like this. And then we're going to go ahead and graph the transformation. So this is, the negative 1 is down 1. And then, so that means that we're starting at negative 1. Remember what the 2 means. That is a vertical stretch. So our graph looks somewhat like this. Okay, so our domain here, again, the x is going to be from negative infinity to infinity, all real numbers. That should be a parentheses. And range starts at negative 1 included, and goes all the way to infinity. That does not stop. Our y-intercept is going to be um, 0, -1, and our x-intercept is something that we need to calculate here. It's crossing the x-axis, so we need to know what that is. So x-intercepts, that is when we plug in as y equals 0. So 0 equals 2x squared minus 1. We add 1 to both sides. Now we're isolating the x on the right side, which we can totally do. We divide by 2 to get rid of these 2's. So we get a half equals x squared. To get the opposite operation of x squared is a square root. Now when we take a square root, we need to add a positive and negative um, also. So what did we get here? We have x equals a positive and negative square root 1 over 2. Now, square root of 1 is 1, so we can rewrite this as square 1 over square root of 2. So our x-intercepts, there's going to be 2 because there's a positive and a negative. So our first one is 1 square root of 2. Let me write that a little bit. So negative 1 square root of 2, 0, and positive 1 square root of 2, 0. So these both are our x-intercepts. Okay, next one here is a square root. So our parent function looks something like this. Our transfer function is 1/3 square root of x minus 1. So this means that we are going right 1 because it is it's underneath the square root. So the function is going to start right here. Now, it's 1/3, which is less than 1. So that means that it is a vertical shrink. So it's going to look something like this. Our domain, it starts at 1, so 1 included, 1 to infinity. Range starts on the x-axis, so going from 0 to infinity. Now, looking at y-intercept, this does not cross the y-axis or touch it, so is no y-intercept. For the x-intercept, that's going to be the 1, 0, the ordered pair. Okay, let's move on to look at piecewise defined functions. So a piecewise defined function, just like the name kind of says, piecewise, it is a function with a multi-part rule. So here, we're going to graph each piecewise function using a different color to graph each piece if possible. Remember to start and stop at the domain break, even if it is not included in that piece. So let's look at this first one here. So notice that what's happening here is that we have two different x's. So we have an x is less than and equal to 1, and we have x is greater than 1. So what that means is that we've got the two different parts. It looks different depending on if x is less than 1 or if x is greater than 1. So for this first part, it means that we have y equals x plus 3. And now what we need to do is we need to start x, so we need to start with the 1. So I'm just going to make a table and just plot the points here. So 1 plus 3 equals 4. So our first point is going to be 1 to 4. 1, 1, 2, 3, 4. There's our point 1 to 4. And it is included because we have that line under, so I can do a solid dot there. Now, notice that this is x is less than 1, so we're going to have to go down to 0. 0 plus 3 equals 3. So 0, 3, which is our y-intercept right here. And then negative 1. Negative 1 plus 3 equals 2. So I just picked the easiest points to plot. Negative 1 and 2. So that's our next point. Now, graphing the this one, let's see if I can get this to turn. There we go, but the wrong way. Okay, you know what? I'm going to ignore that and just draw it, sketch it with. So we start from the 1 and keep going down like this. That is our first part. Our second part here is when x is greater than 1. And now with that, the 1 is not included. So that's going to be a circle. And x or y equals 4, we're just going to draw a straight line, y equals 4 like this. So sometimes you might see where the piecewise function, these are on the same point, like start and stop at the same point. But sometimes you might see where the piecewise function, for example, starts from here and goes that way. And then the other side, the less than side, starts somewhere else. So there might be like a little bit of a difference between those points. And that's when it is even more important to do the circle or the closed dot to like say that, okay, this is, this is included, this is not included. We can't, again, we cannot have these both included if it is a function. It does not pass the vertical line test. But here, where we have the same point in this example, it's one of them, it's going to be a closed dot because the x, this one includes the 1. Okay, let's look at this next one. Now, it's x is less than or equal to negative 2. And we have the same equation, y equals x plus 3. Again, the best way to do this is to do a table now and start with negative 2. We're going to go down negative 3, negative 4 because we need less than. Okay, negative 2 is negative 2 plus 3. That would be a 1. So our point is negative 2 and 1. Negative 3 plus 3 is going to be a 0. So 0, negative 3. Sorry, that went the wrong way. Negative 3 and 0, of course. And then we've got negative 4 plus 3, which is negative 1. So negative 4 and negative 1. Okay, so plot the points, negative 2 and 1. And that is a closed dot because it is included. Negative 3 and 0. And negative 4 and negative 1. There we go. And the graph goes down here like that. Now, the other part here, negative 2 is not included. We still need to calculate that negative 2. so that we know where it starts. That would be the circle. So we're going to start with -2, negative, no, not, we're going the wrong way. Going up, -1 and 0. And let's see if we can get enough of a graph from that. We might need to do another point because this is a quadratic function. So 1/4 times -2 inside parentheses squared. So this is 1/4 times 4, which is a 1. So our point is -2 and 1, which happens to be the same point that we already graphed here. Our next point is going to be 1/4 times -1 squared. So -1/4 times 1, which is, where did I get the negative? Not, this shouldn't have a negative. Which should be, it's a 1/4. So our point is -1 and 1/4. Well, that's going to be interesting to plot. It's somewhere right here. And then we've got 1/4 times 0 squared, which is 0. So that one goes through the origin. Now, we're going to need another point here to know where it's going. It is a quadratic, so it should look like a parabola. So 1/4 times 1 squared is going to be 1/4. So our next point is 1 and 1/4. So we see that it's going to start going up. If we do one more where we do 2, it would be 1/4 times 4, 1/4 times 2 squared, which is 1/4 times 4, which is 1. So it's 2, 1. 1, 2, and here we go. So what this looks like is it starts going up here and goes up like this. So x is greater than -2 is the quadratic, and x is less than or equal to -2 is the linear. Okay, moving on to the next example here. Now, x is less than or equal to 1, we have a negative absolute value. And again, the easiest way to figure out the points to make sure that you are on the, graphing it correctly is with the piecewise function is just to plug in. So we start with 1. So negative absolute value of 1 is going to be -1. So 1, -1 is our first point. 1, -1 is right here, and it is included. We're going towards the smaller numbers, so we're going to do a 0 next. Negative absolute value of 0, well, that's going to be a 0. So we are going through the origin 0, 0. Next, we're going to plug in -1. So negative absolute value of -1. So this ends up negative, absolute value of -1 is 1. So it ends up being a -1. And our point is -1, -1 right here. We can do a fourth one, -2. Absolute value of -2 is 2. So this ends up being -2. So -2 and -2 is right here. So we're going to start here and go down, 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 like this. Okay, now the other side. So x is greater than 1. X and y equals 2x. So again, we need to start with the 1 just to know where that point is, where we're going to draw the circle. So 2 times 1 is going to be 2. So our point is 1, 2. And as you can see here, we're going to draw the circle because it's not it's not the same point as what the x is less than or equal to 1 is. This point is not included. We still need it to know where to start it. Okay, greater than 1. So we're going to go to 2. 2 times 2 is 4. So our next point is 2, 4. 1, 2, 1, 2, 4 right here. And then next one, 2 times 3, which is 6. So our next point is 3, 6. And now we should be able to draw it with the 3 points. We always want 3 points just in case we make a mistake in one. So we can see that we're graphing it the correct way. Okay, that's piecewise functions. Now we're going to look at an application here. We have a cell phone company that offers the following plans. Write a piecewise function to represent each plan and graph on the same set of axes to compare which plan is best. We have a plan A and we have a plan B. Okay, for plan A, $30 per month buys 120 minutes. Additional time costs 30 cents per minute. So if we think about, we have a function here. One, the first part is going to be the $30. And then the next part, additional time costs 30 cents per minute. Now, this one's a little bit trickier. So, okay, hold on. Let me take back. So when we $30 buys 120 minutes. So that means that this is if you pay $30 whether or not you talk 120 or not minutes. So this 30 is good up until 120. Now, when we exceed the 120, so when it's going to be greater than 120, that's when this additional 30 cents comes into play. And the way we're going to have to write the function, well, you're going to pay the $30 anyway. So that's not going to yeah, oops, sorry. It keeps me I keep putting my hand so that it moves. So, we're paying the $30 anyways. But now, how does this 30 seconds? That's an additional time. So we need to subtract the time, or we need to subtract 120 from that time, and then multiply whatever that time is by the 0.3 here. Now, I don't have enough room here. Let me rewrite this. Okay, so again, this x minus 120 is the time that exceeds the 120, and that is what we are multiplying by the 30 cents. And this is when x is greater than 120 minutes. Now, we need to graph this. So this is our plan A. Well, we're going to first have to figure out how the graph goes. I'm going to put down here in increments of 60. In increments of 20, sorry. So that's 120. I can't fit all these in. 140, 180. So 160, 180, 200, 220, 240, 60, 280. And that would be 300. And so on. So these are the minutes. And then up here on the y-axis is the cost, the dollars. And we're going to start with 0 and go in increments of 5. So 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, and 60. There we go. Okay, so when we are graphing plan A, we've got 30 when x is less than or equal to 120. So 120 is right here. We go up to 30 right here, and that is included. So this is a straight line to the left, like that. Now, how do we graph when x is greater than 120? Well, we're going to have to do some solving before we graph it. So I'm going to go ahead and do it on here. So we have so this is our plan A. We have our y equals 30 plus x minus 120 times, not 0.03, 0.30, like this. Okay, so what we're going to do here is we're going to have to distribute this first. Actually, not equal sign. So y equals 30 plus 0.30x minus 120 times 0.30 is going to be negative 36. Now we can combine these, so we get y equals 0.30x minus 6. Okay, what we need to do next is we need to use a table to plot a couple of points. So y equals 0.30x minus 6. And again, we need to start with x equals 120. So negative 30 times 120, even though that 120 is not included, we still need to know what that number is. So this ends up being 30. So our first point is going to be 120 and 30. So 120 and 30, well, which is the same point as we already have. Now we're going towards the greater numbers. So let's plug in, for example, 200. All we need is 3 points somewhere. Not y equals 0.30 times 200 minus 6. When we plug this in the calculator, we get 54. And let's do a third x. Let's just do 220. 0.30 times 220 minus 6 gives us 60. Okay, we're going to plug in those points. 254. 200 is here, and 54 is going to be right underneath 55. So there's our first point, and then our next point was 220 and 60. So 220 and 60 is right here. A straight line all the way through here. There we go. So that is our plan A. Now we're going to need to look at plan B and see what that looks like. So plan B, $40 per month buys 200 minutes. So the same thing, $40, X is less than or equal to 200, right? So $40, 200 is right here, and 40 is here. That is included, so that's going to go to the right like this. Now, additional time costs 0.2 per minute. So it's going to look the same as we did on the plan A. So we're going to pay $40 anyways. Then we need to subtract 200 to find out from the minutes altogether to find out how much time is exceeded. And then this costs 0.20. And this is when x is greater than 200. Okay, we need to do the exact same thing for plan B now that we did for plan A. So y equals 40 plus x minus 200 times 0.20. We distribute this first, so y equals 40 plus 0.2x, and that ends up being minus 40. Minus 40 and plus 40 cancel each other out. So we end up with y equals 0.2x. And now, remember with this one, we are starting at 200. So x 200 is not included, but we need to still calculate what it is. So zero point 0.2 times 200 is going to be 40. 2 times 2 is 4, and we're dividing by a decimal, so we take out 1 0 because it's the tenths place. And then let's plug in 240. 0.2 times 240 is going to be 48. 300 is the next one that we're going to plug in, and that is going to be 60. So we're plugging in those points. 240, which we already have, 240 and 48. 240 and 48 is right here, and then we had 360. So 300 all the way to 60 here. And it does not stop. I mean, it keeps going and going up. Okay, that's it for this lesson. Again, please don't hesitate to ask any questions about it. Bye.